Okay, let's work on an example, exam 1. Looks like it was the exam that was given in fall of 2004. Anyway, here is sample exam. The first problem says find the state space form for the system expressed by the following transfer function. H of s is s plus 5 over s plus 1 times s plus 4. It doesn't say which method we have to use, so we can use, you're free to choose your own method. Let's rewrite the system here. And so since the transfer function is given and it's already in factored form, I think I'll just do the partial fraction method or the parallel method. And so we'll say this must be equal to sum a over s plus 1 plus b over s plus 4. A must be equal to, we think of multiplying both sides through by s plus 1. They cancel out on this side. And then if we let s equal -1, this term goes to 0. And all we have left is this term without the s plus 1. So we have s plus 5 over s plus 4 evaluated as s equals -1. And plugging those in, we get -1 plus 5 over -1 plus 4. And so that looks like about 4/3. B, similar process, s plus 5 over, multiplying through now by s plus 4, we have s plus 1 on the bottom, we let s equals -4. And we have -4 plus 5 over -4 plus 1. And that looks like 1 over -3, -1/3. Alright, so we can look at it in terms of our simulation diagram. We'll have two parallel integrators here. They come out to a block and then they're going to go off, and we have feedback here. So let's say this is the -1 block for the first term, so this will be A, which is 4/3, and this is going to the output Y. This is coming from the input U. Alright, and feedback, and then it feeds over here, and then the second one, our root is -4 over there, and then our B was -1/3. These sum together, put the summer in there to give us Y, and U comes into both of these from over here. Okay, and so then we'll define our states, x1, so this must be x1 dot, and call this x2, and here's x2 dot. And we can write our state equations then from this side. X1 dot is -x1 plus u. And x2 dot is -4 x2 plus u. And then also y is 4/3 x1 plus -1/3 x2. So that's going to give us our, we can just write down our state equations now, or we can write our ABCD matrices. A, coefficient of x1 is -1, coefficient of x2 is 0. Let's go ahead and do B while we're at it. Coefficient of u is 1. X2 equation, coefficient of x1 is 0 and coefficient of x2 is -4. And so this method is nice because the partial fraction method takes a little work doing the partial fractions, but then it gives you the Jordan form. And let's see, and then the u is just a coefficient of 1. The output matrix is right, our output equation is right here, so C is 4/3 x1 and -1/3 x2. Okay, so there's number 1.